Hi, this is Adam from MakerState, and I'm back with our third webinar for the Maker Fellows program. In this webinar, I'm going to discuss Applecatcher. Before I get into that, just some notes from some school visits that I've started to do. First, make sure you build your prototypes ahead of time and show them to your students during the discover phase, right? And kind of to tie in the next point, it's really important that your students see the full scope of where a challenge is going before they start building it, instead of just having them build it and, be working towards something that they don't exactly know what that something is. So just make sure you're in that discover phase providing, full context to the challenge and showing where they're going to end when they are finished creating their prototype. Okay? And along with that, using the design cycle and the magnets to guide your students through the design cycle and really highlighting the discover, create, and improve phases as you go through them. If you don't have a design cycle poster, please let us know and we'll get one to you immediately. That's one thing I found at One Makerspace this week. And again, just highlighting these three phases and trying to, we're not just trying to teach students the specific technological and programming skills that they get from working in Scratch and these other programs. We really want them to also take with them this design cycle process and this method of problem solving that's really useful for engineers and people solving all sorts of different problems in many different fields. Finally, hand out your rubrics at the beginning of class and encourage your students to use them as they go through the challenge rather than giving them out at the end and having them do them at the end of class. It's really easy to run out of time to do them if you do them that way. So if you hand them out in the beginning, then they'll have them and they'll be thinking about them throughout the challenge and hopefully filling them out as they're going through the different steps of the challenge. Just a couple other general notes. I will not be doing the office hours this week and next week. Instead, Noah, who's another knowledgeable MakerState Maker Fellow, will be handling the office hours. I'll be back in 2 weeks doing them, but he'll be there answering your questions this week and next week. Also, we have Scratch Skills lessons 1 through 16 up in the Scratch Skills section of the STEM Collab. So go check out those Scratch Skills lessons there. And similarly, we have Scratch debugging challenges up 1 through 3, and those mirror exactly the first 3 Scratch basics lessons that you've done. 1 debugging challenge for each lesson. So those are good ways to test your skills and your programming abilities on some programs that you're somewhat familiar with. And finally, just want to make sure we're encouraging everyone to continue using those STEM Collab digital resources, those quizzes, and completing those prep and practice prompts. Those are really helpful for us, just to see how you're interacting with the lessons and how, hear about how they're working in your classrooms, and also so that you can see each other's best practices and hear about how some of these things are working in your schools as well as us. Okay, so with that, let's get into our challenge. Scratch Basics number 3, Applecatcher. For this, you need your standard group of Scratch materials, charged computers, internet, optionally your printed Scratch blocks if you want to show or prototype some parts of the code beforehand, rubrics, and parent reports. And in our discover phase here, we're talking about variables and using variables to store information. So in this project, variables are going to store information and they're going to represent the score in this game specifically. So some opening questions you might want to ask are, what information does a computer store? And why is it helpful for computer programs to store information, right? So, computers store all sorts of different pieces of information, and it's easy to think about, today why we might be afraid or, skeptical of computers storing specific information. But in general, storing information is a basic function of computers, and we should think about why it's important and really useful to store information, especially as we move towards writing our own programs. Okay? So with that, I would show how to use variables in Scratch projects, which we'll hop over to Scratch in just a second, and show your prototype and introduce the new Scratch box you're going to use. Pick random or greater than and repeat until are some that come to mind immediately, but let's jump over to our project and take a look at some of our blocks in here. So, you have the whole video on how to build this in the STEM Collab already, but just to highlight some key points that are happening here. So we've created a new variable using data. Again, we click make a variable, type in the name of that variable, and then once I click OK, this will appear as a variable. I'm not going to do that because I don't actually want another variable, but I can use set and change to change or set the value of that variable. So in this program, we're setting score to 0 at the beginning of the program, and then we're adding score by 1 every time we catch an apple, or resetting the score to 0 every time we miss an apple, okay? And the basic code for this apple here is at the beginning of this loop, the apple goes to the top of the screen with a pick random block to set a random X position between -240 and +240, which is anywhere along the top of the screen, being the Y position of 180. And then we repeat until touching the bowl or Y position is less than -180. So Y position being less than -180 is what will happen when this apple hits the ground. And you can see over here, if you watch these numbers, as I drag this apple down below the bottom of the screen, we get to below -180, we're at -200 right now, etc. So one of those two things will trigger the end of this loop. But until that happens, we're going to change Y by -10 and keep falling downward. When one of these two things happens, we check to see if we're touching the bowl. If we are touching the bowl, that means we've been caught by the bowl, so we use the pop sound and we add 1 to the score. Otherwise, we set our score back to 0 and we play this chop sound. Okay, so just to demonstrate that. The only code I'm using for the bowl is just this simple right and left movement with if-then blocks inside of a forever loop. Okay, so one thing that could be cool to do to this, just to improve it a little bit, would be to make the apple fall faster the higher the score. Okay, so the game will get harder as you keep playing it. And the way we can do this is by manipulating this -10 inside this change Y block here. And what we have is we have this score variable that's going to increase and get higher and higher as we score more points. So what would be cool is if we could find a way to use score to make the apple fall faster. Okay? So one thing that falls to mind is if I said, okay, well, if this needs to be a negative number, I could go to my operators and maybe I could take a minus number, and unfortunately I can't just type negative score in here. I can put score in here, but to make score negative, I need to put it inside a minus block like this. And so we could do set Y to 0 minus score, and so then whatever my score is, the higher my score, the faster my apple will fall. Let's see how that works. Okay, well that creates a problem because we start at 0. What if we start at -1 instead? Okay, that's a very slowly falling apple. What if we make this start at -3 instead? Okay, good. And now we can see slowly that the apple is starting to pick up speed. 5, 6, 7, 8, and now it's starting to fall really fast, and pretty soon there's no way I'm going to be able to keep catching it. Okay, and then when I drop the apple, it resets its speed back to this -3. So, again, how this is working is when our score is at 0, we are moving the apple downward by -3 pixels, per loop, and then as the score increases, we fall faster and faster. So there's a really quick hack just using our variable that we already created and a minus block from operators to make this game more difficult as you play. And there are a lot of other fun things you can do with score, as far as, maybe if you wanted to change the object that was falling or add a second object that was worth a different amount of points. Those are some other fun, extra challenges that you can do on top of this one. So I encourage you to play around with those ideas or some other improvements that you can think of. Okay? Another thing I'm going to show you quickly is the debugging challenge that we have for this. And you can get to that in your STEM Collab here in the debugging exercises. And you can see that here we have the working version of the project, the one I just showed you, not without that score hack. And then you have a link to a bugged challenge here. So let's go to the bugged challenge, and here, if we try to play this, the apple's not, okay, I'm pressing the arrow keys here, but the apple isn't falling the way it's supposed to, and this bowl is not moving the way it's supposed to. So there are a couple errors that need to be fixed in this code over here to make this game work like the original apple catcher that we made before. So, maybe after some of your students finish, or as a do now for the next class after doing this makerspace, you can use this debug challenge to test some of your students' knowledge on this. Okay? So I hope this was a helpful webinar, and hopefully you have some fun ideas for how to complete and kind of go beyond and extend on this apple catcher challenge. And thank you for watching. So hope to see you at the next webinar, and until next time, bye.